No, next we discuss about secant method. That secant method that seems to be the similar with the regular falsy method, but the difference is it was the chord method and it is now we are discussing it is the secant method. That's the find the exact function, exact value of the function. Say cos x is equal to x into e raised to the power x by using secant method. Here we are following secant method. Find the exact value of the variable, it means x, by using secant method. Now here it is a function. We can write this function in this form: f of x is equal to cos x minus x into e raised to the power x. Then again the problem is where is the approximate value of the x. How we find that? Again we follow the same procedure by hit and trial method. Say f of 0 is equal to cos 0 minus 0, that is equal to 1 minus 0, that is equal to 1. If we see the value, again we have to see the values in the radians from your system, which either you have calculator or you have operating system. No. Next, say f of 1, that is equal to cos 1 minus 1 into e raised to the power 1. That is cos 1 is equal to 0.5402 minus 2.718. E raised to the power 1, again we can find it from the our calculator or the given system. That comes to be, that is equal to minus 2.718, and it is less than 0, it is greater than 0. It means we got the first oscillation, that the value of the variable changes from the value of, when we change the value of the variable from 0 to 1, the value of the function changes from positive to negative. It gives us the hint that the value of this function lies somewhere near 0 and 1. Again we consider the same formula which we considered in the regular falsy method, but we differentiate this method by certain steps. Here the formula was x2 is equal to x0 into f of x1 minus x1 into f of x0 divided by f of x1 minus f of x0. That is the same formula which we used into the regular falsy method. So what will be the difference? That we will see in the further step. So again we consider the smaller value. It is say x0 is equal to 0 and x1 is equal to 1. Smaller value x0 and greater value x1. Then what is x2? x2 is equal to, we put all these values here, x0 that is equal to 0 into f of x1 f of 1 minus x1 into f of 0 divided by f of x1 f of 1 minus f of x0, that is f of 0, that is 0 minus here f of 0, that is 1, divided by f of 1, it is minus 2.718 minus f of 0, that is equal to minus 1. And if we calculate it, it will give 1 upon 3.718, and that's come to be 0.3145 5 approximately. Now we change our procedure which we followed in the previous two methods, in the bisection and Dragula-Falsey method. No, we do not consider the number line. We are not going to divide the number line into the two parts, but we are going to change our values of our variable. How? Let us say this is x2, the next value is x3 is equal to, here x0 we take x1 and x1 changes into x2 minus x2 into f of x1 divided by f of x2 minus f of x1. Same formula by changing 0 to 1, 1 to 2, 0 to 1 and 1 to 2. We get the second step. So in the second method, we need not to divide the number line again and again to find the exact value of the variable. Now here x3 is equal to this, we put the values. x3 is equal to say x1 1 into f of x2, that is f of 0.3145 minus 0.3145 into f of x1. F of x1 means f of 1 divided by f of x2, f of 0.3145 minus f of 1. So we consider this equation number 1. Why? Because this value is unknown. This value is unknown. Now we can calculate this value again with the help of the given function, that is f of 0.3145 is equal to cos of 0.3145 minus 0.3145 into e raised to the power 0.3145. Again we can find the values from the system. Here again we have to check the values in the radians, that is cos 0.3145, that's come to be equal to 0.9509, by approximating, minus 0.3145 into e raised to the power this, that is 0.3145, that comes to be 1.3696 by approximation, that is 0.9509 minus multiplied, that is 0.3145 into 1.3696, that comes to be minus 0.4307 approximately, and that is equal to that is equal to 0.9509 minus 0.4307, that's equal to 0.5202. Now we can put all the values here in the equation number 1. From 1, what we get, that is x3, that is equal to 1 into 0.5202 minus 0.3145 into f of 1. F of 1 is already present, that's equal to minus 2 approximately it was 18, divided by f of 0.315, 0.5202 minus f of 1 minus 2.18 it is approximated value. Then that is equal to 0.5202 minus plus, that is 0.3145 multiplied by 2.18. That's come to be 0.6856 divided by 0.5202 plus 0.6856, that is equal to 1.2058 divided by 2.7002. It is 2.7002. That comes to be 1.2058 2.7002. That's equal to 0.4465595. That in the second step we got the value up to decimal 8th place. That is the main advantage of this method, second method, over the regular falsi and the bisection method. It does not require that steps every time we are going to divide our number line into the two parts, again into two parts, again into the two parts, but simply what we do, we shift the values, we change the variable values and find the next. Similarly, we can find the next step, say with the x4, that will be equal to here x2, x3, x3, x2, x3, x2. Shift 1, 1, 1 in every step up to the last stage when the values, last two values are very close to each other, or we can say approximately equal. Then we stop this process. That may be after 5 steps, 10 steps, 20 steps, maybe 25 steps. Here only we follow 2 or 3 steps. That is the second method to solve the given equation, your given function for the